for holding on. Sorry for the delays. We had a few issues back here in the office that we're sorting out. Not fully solved, but I hope our call is not affected. Yeah. So an introduction. I am Paul Asitek. I'm in center here in Amalitech. I'm here today to take us on a prep session, prepare us for the GCA test, which we are all getting ready to in a few weeks, right? Basically, we are just going to get to understand some of the tricks or some of the things that we need to know pass the test, right? I'm here with some others from Amalitech. I'm sure while we're figuring out the issues over here, you heard a lady's voice. That's Lois. She's with the CSR department. She's also off. I'm sure she's off right now, trying to also continue with where I left off when it comes to whatever issues we're facing. Yeah. I have here also Michael. I'll allow him introduce himself and then we'll continue from there. That's if he's Mike, are you able to speak?
Good morning, everyone. My name is Michael Ferdinand Sopoteno. I'm with CSR. Here to support.
All right, thank you, Michael. All right. I don't know if the others are here. Francis, are you here? Francis and Davis, any of you here?
Yeah, so currently I learned Kumasi Internet Tools also now. So Francis will be joining late. But my name is Prince Davis. I'm with the recruitment team. Can you hear me?
Yes, we can hear you.
Okay.
I'm sorry.
Okay.
Paul, before you come in, Prince David, please, there's a comment in the chat for you to attend to. This comment is bigger than me. So it's in your domain.
Yeah, so I think the prep session is for you to take the assessments again. But the problem is you can't take the assessment with the same email. So you will need a different email account to take the assessment. I don't know if that's answered your question.
Okay. I am hoping Jeremiah. Hey, sorry, German. I'm hoping German is fine with the response. If not, you can always let us know. All right. So once again, thank you for we are here to go through our prep session. Again, if you've already taken the test, then you are just here for the vibe. If you've not taken the test, you are here to prepare for the test, right? What would this, okay, yeah, let's just move on. We get to understand what we will cover. So, yeah, what are we, why are we here today? As I said, we are come to prepare for the GCA. What are we covering? We are covering a framework that is going to help us code DSA questions in general. We are going to also understand the context of the GCA test. And then we are also going to try our hands using the framework that we learn in step 1. We are going to try our hands on some DSA task. One easy task and then a medium level task, right? All right. So before I go through this, basically how the breakdown of whatever you're going to be doing, so we'll not spend so much time here. Before I come to this, I would say we are not here to actually learn the DSC from scratch. The assumption is you've already covered the fundamentals in the university and on your own. So this is not a place where we are coming to learn what an array is and array manipulation and all of those things, right? We are going to instead learn something else and how to approach tasks. So given the knowledge we have, how if they give us a question to solve, how are we going to approach it? So we have more about the approach than the nitty-gritties, right? Okay. The sorry, what's the GCA actually tests, right? Now we always wonder why is it even necessary to take a DSA test before coming into a company? Why do a lot of companies prefer this route and all that, right? Now, the first thing is the employer or the recruiter wants to understand how much how much of the fundamentals you understand. So we want to get a picture of how much of the fundamentals you understand. Do you get it? Because if your fundamentals are weak, then it's going to be much difficult working with such a person, right? So the fundamentals basically are the data structures that we already know of, things like loops, things like conditionals, and the various other data structures we have, right? And also syntax. So if you say you use a certain language like Python, like JavaScript and the rest, we want to see if you really get the syntax of those languages. So these are the things that one of like a group of I would say the first group of things that we are trying to see with the DSA test known as the GCA, right? Now, the second thing that we try to also understand is your thought process, right? Under pressure. Very important, thought process under pressure, because people left to think without time limits and all those things might be able to do that freely, but what if you are put on a project where a critical project that has critical timelines and all those things? How are you going to act under pressure? Are you going to skip important steps? Are you going to make compromises and all those things? The quality of your output and all those things, right? And this is a good way to use what you already know from the university to test your thought process under pressure. So we look at are you going to still follow the normal problem solving route of breaking down the problem, planning how you are going to approach each piece of the problem, and then finally executing the problem while you are working within a time frame or while the clock is ticking. How are you going to approach this? That's one of the things that we also try to see with the GCA or DSA test, right? Now, the last would be problem solving approach, right? So how quick are you to spot patterns? Basically, this is what we talk about here. So you see a problem, although you don't have every problem is unique on its own. There are patterns that run through like a number of problems, right? And when you spot the patterns, how are you going to use it to quickly come to a solution specifically for that particular problem, right? So these are like the three things that the DSE test or the GCA tries to understand before you get into the company, right? Okay, a second. All right, now the honest truth. I don't like DSA, and most developers don't like DSA. That's the honest truth. Most of us here don't like DSA too. I remember when we were in school, a number of us uh, just didn't like. By the way, I attended KNUST, right? And we had this professor who taught us data structures and algorithms. We didn't like his class because every time we have to think on the spot. Yeah, so it's normal. I know a lot of us here don't like it, but we have to learn it. It's necessary, right? So the fact that you don't like it doesn't mean you are a shitty developer or like, yeah, it doesn't make you less of a developer or something. You just have to take it as something that is necessary and build your skill around that. Today as we talk, if we decide to pick some developers and give them some DSA tasks to solve, a lot of them are going to fail. A good number of them are going to fail the DSA test because they haven't consistently been practicing. I think that's a skill you build based on more practice. As we mentioned in the previous slide about pattern recognition and those things, the more you solve, the more you discover certain patterns, and the more you can reapply your knowledge from previous to solve new problems. Yeah. Somebody wants to talk? Okay. I mean, you can raise your hand if you have anything to say at any point. I would pause and then listen to whatever you want to say. Yeah. All right. So another thing you have to know is what you think, I don't know, what you think you have, or it says what got you here is not enough. So basically, the boot camps you think you have taken, yeah, Zagla. Zagla, you're here again. You haven't taken your test yet.
Yes, please. Thank you. That's what I wanted to ask. I was part of the last session, but I've not received my assessment link yet. And then this link was sent to me. So I want to know if I'm supposed to be here or it's the same thing we are going to go through.
Yeah, it's the same thing we are going through. It's okay. Davis is not here. Francis joined? Francis. No, Francis is not here. Prince Davis, Zagla says he has not taken his test yet. He has not gotten his test yet.
Okay, he should just drop his email in the chat box.
All right.
Let me look through this application. Okay.
All right, sure. So Zagla, yeah. I mean, it's the same. There's a second session for another group of people who haven't had their session yet. So yeah, it's basically the same thing that we are doing for 3 times for different groups of people. So if you want to attend to something else, feel free to drop off. Yeah, Amma.
Please, I have the same problem as Zagla. So should I also drop my mail in the chat?
Yeah, drop your mail.
Yeah. So whoever has that same problem, please kindly drop your email in the chat box.
All right. Let's go on then. All right. So yeah, your certificate from the university, your certificates from Udemy and all those things are not going to be things that will help you pass this, right? What is going to help you pass this is, sorry, what is going to help you pass this is you actually like knowing what you're doing. I don't know how to put it. So the best way to put it is practice. So no matter who you are, even a software developer before taking these tests would go back to practice and practice and practice before taking the test. So you are expected to do same, right? And familiarity beats cleverness. Yeah. It's the same idea here. Practice, practice, practice. You have to practice to be familiar with certain patterns and all those things, right? And that's what's going to help you pass the test. So the summary of this slide is practice. It's not what I'm coming to see here that is going to make you pass. It's not what your lecturer said that's going to make you pass. It's not the boot camps. It's not the YouTube that you have been watching that's going to make you pass. It is practice. You're supposed to practice and practice and practice, especially as the date is coming closer and closer, right? All right. So yeah. So what does the GCA look like? You're gonna have 70 minutes to solve 4 tasks, right? That's basically what it looks like. So you have 4 tasks and you have 70 minutes to complete the 4 tasks. Now the 70 minutes is not split between the tasks. You have to manage your time yourself. So you decide how much time you are spending on each task, right? the pass mark is 350, as you can see. That means once you hit 350, you are good to go. Your aim is to cross the 350, right? That's the pass mark. We also, another thing to notice, partial credit is awarded to submitting partially completed task. You understand? So if you have, let's say you were able to build part of the solution, and then your test cases, a number of them are passing, don't say because you haven't completed the task, you are not going to submit everything. One trick I always advise people to use in solving this DSA task is, if you have a solution that is passing some test cases, right? Please take solution that is passing some test cases and not all test cases. And then to make sure that it passes all test cases, it means you have to tear down everything you've written and all those things. Don't do that. Just comment it out and then start the new idea that you are trying to use to pass all test cases. If time is beating you, comment that new idea out because it is still not done yet and maybe it's not passing enough test cases. You can comment that out and uncomment the first one because that one was passing more test cases, right? If you delete it, it means it's not there. Like you don't have a backup to fall on if time is beating you. These are tricks that you use within the test to be able to like make it or excel, right? Yeah. And don't waste too much time on one task, especially task one. Task one is usually the easiest task. So the four tasks are of increasing complexity, right? So task one is the easiest. Task two is a little bit difficult than task one, but second easiest, and it increases like that, right? So don't waste so much time on just task one. Your focus should be on passing task one and task two, right? So you spend time and make sure that your task one and task two, I've finished it. I'm done. That one is working. You understand? Then just a second. Yeah, Prince, we have something in the chats. Probably you can look at it. If you want to respond, you can prompt me. I would pause and then you can respond. If you want to also type, that's fine. Yeah. So as I was saying, focus on passing task one and task two. Task three and task four, you can try to just pass some test cases over there, right? But mainly put a lot of energy to pass the first two. If you can pass the first two and pass a few test cases in the other two, trust me, you are going to make it. You are going to hit that 350, right? So this is a trick to pass it to get the 350. Don't I don't know, don't I don't know how to put it. Don't be scared. Like you don't need to finish everything to hit the 350 mark, right? Just focus so much on task one and task two, try to complete them, then finish, get a few test cases to pass for task four and task three, and you'll be good to go, right? That's how you can hit the 350 pass mark, right? So that moves us to the framework, right? Now, before I move to the framework, there are other things I want to talk about which makes us fail or which affects our GCA score, right? Before I talk about those things, Moses, you can come in.
Good morning.
Good morning, Moses.
So, I have already taken the test, and you guys said the pass mark was 350, but mine was 303. Should I mean, if you could give me the opportunity again, I'll fine. But if not, so then I guess this meeting is of no use to me anymore.
Yeah,
Okay.
so Prince.
Let me take this question. Okay, so what was the pass mark for the cognitive reasoning assessment?
350.
Yes. So putting together, you've not passed. When you
Okay.
fail the cognitive assessment, you should score 470. Then when you score in the GCA 300, you are considered. Now, when you should score 450 in the cognitive assessment, then you should score 350 in the GCA and above. So we are figuring out how best you can score 350 plus that we will consider you with a GCA. Okay.
Yeah. So right now, what's the this thing? Because I think I scored 400 and this thing in the cognitive. No, not the cognitive. Your other one, the attitude test uh, questions. So
Kindly send me your email. Okay. Put your email in the chat box. Let me check from our end.
okay, thank you.
All right. I'm back. Yes, so I think Prince has given you guys Moses, you have something else? Okay, yeah, sure. So I think Prince has given you guys more apple, yeah. Um, so yeah, you know how to balance your game. Anyway, I was saying that another thing that makes us not make it is not the fact that we didn't hit the 350 mark, right? Um, some of the things are just instructions. One thing that happens is we rush our way into taking the test and we don't follow the instructions before taking the test. So before taking the test, there are instructions like you're supposed to have your camera on, you are not supposed to switch between tabs. These instructions to ensure that you complete the test your with with Anna, I would say Anna, yeah. So probably no cheating or something, right? So these things that have been put in place will be given to you as instructions. There are things you are supposed to do, upload your ID card in a certain manner and all those things. You are you are supposed to read these things well and comply, like comply giddy giddy, because you can hit even 600, you can get all the 600 points, and because you didn't comply with these instructions that were given, your test is rubbish, it's thrown away. We don't even consider it. So these are things you want to look out for when these are things to look out for when you are taking the test, right? Yeah. So yeah, follow instructions. That's the number one thing. It should have been the first thing in the slide. So when you entered your test room and then you are trying to take your test and all those things, I mean, focus on the instructions and follow them. Make sure you are following them. If it's requesting any information, you are giving the right information and all that, right? Okay. I think in the previous session too, somebody complained about typing speed, was like code signal flag team because of typing speed and all those things. I was researching into that and I noticed that code signal is able to detect your keystrokes, right? And they use that to also determine other things. A normal way of solving problem would involve brief pauses to think about the flow that you are typing out, right? And also the speed at which you type also is counted. Now, if there is anything that is found out, like maybe the system detects that the typing speed was insanely high and there were no breaks to like think about the procedures you are implementing and all those things, it will flag your solution, right? It will flag your solution probably because we can see it wasn't typed by a human, or also because probably the solution is somewhere and we are just reproducing the solution, right? So these are things that we have to, these are things that we have to, these are things that we Sorry. Yeah, sorry for the distraction. So these are things that we have to take note of when we are solving our test, right? Now let's go to quickly move to the framework. Again, this framework is not, we are not trying to teach you DSA from scratch. That we assume you already know. What we are trying to help you out with here is the approach, what you are supposed to do, or like how you are supposed to approach DSA tasks, not just jump into them and start figuring your way out from the beginning, right? But take your time, break down the task, and then implement it, right? So the normal using a normal problem solving approach to face the task, the various tasks that will be given to you, right? Right. So now, the first step here we have is saying read twice. You might think that, oh, it's not necessary. I read the first time, I get it, I start solving because I don't have time, right? That's what your mind is going to do to you. You're going to feel like you don't have time, so you're supposed to rush. Like, me, I read, let me start implement. Some people, the last time I was talking about it, some of us don't read the task. We would go and read the test cases. That's another, I don't know why we do that, but we read the test cases, the examples. So you read the expected input, read the expected output, and you see the pattern. Then read the second one, expected input, expected output, and then the third one. Then you already feel like, okay, I see the pattern. This is what they want. Then you just hop into coding. Don't do that. You will stress yourself in the middle of building the solution. You would figure out that, oh, what you thought is not what it is, and you would have already wasted time in thinking in a certain direction. You have to now realign your thoughts again, clean everything, come in. It's just messy. You're going to waste time, right? So you read twice. Reading is for story. You read everything, just understand at a higher level what is being required of you. The second reading is now figuring out the constraints. So if it was just a second, yeah. So the second reading is for figuring out of constraints. So if it was, let's say the problem was print out, write a program that takes in a set of numbers and it prints out the even numbers in the given set of numbers, right? You now start thinking of constraints. Is there a limit? Is there a limit of numbers we are working with? Are negative numbers parts? So you are figuring out, you are reading and picking out all the hidden things that were in the question that you didn't capture in the first read, right? Then when you capture these things, you put them down somewhere so that as you move on, right? The importance of this again is just as I said, you might think you have a picture of the problem, then start solving it and you realize that, oh, probably you're working with an array. You realize that, oh, in your when you were working when you were building your solution, you factored in duplicates or you didn't duplicates when the question was saying you shouldn't factor in duplicates, right? In some times, nullifies your whole thought process. Some of you are there, you've experienced this before. You are solving a task, and in the middle of the task, you realize that what you are solving is not actually the direction of the question that was given. Like, and then you are so frustrated that you don't want to clean whatever you typed. So you are now forcing whatever you typed to give you the outputs. So you are forcing to make that solution the actual solution. So you clean this line, try to fix it, clean this line, try to fix it, and you're just going in a constant loop. Your mind is getting entangled. You are having so many knots in your mind because of the entanglements and all those things, right? But it shouldn't be the case, right? You take your time, you read twice, first read story, second read, you pick out the constraints, right? Then the third, sorry, that's the first step. So the second step, I've broken it down into 4 steps, but it's actually one step, understanding the problem, right? And it's somehow overlaps. Now, these steps sometimes overlap, right? Like reading twice. Reading twice will somehow overlap with understanding the problem because of the second read where you are picking out the constraints, right? So understanding the problem is basically a continuation from picking out the constraints. So you see constraints over the step 3, right? So this is step 2 is more of restating the problem to yourself. So after you have read twice in the first step, the step 2, you now say, okay, the question was given to me in this English. I have read it twice. Now let me see if I understand it. So I just sit down without looking at my screen. Sometimes I'll just close my eyes or I just raise my just sit like that, and I'm like, okay, the question is asking me to write a program that accepts an input of numbers um, 0 to 100. It states that negatives are not allowed. Okay, so number 0 to 100, and my output should be even numbers in the given set of numbers, right? And these are the various constraints and all those things, right? Okay, makes sense. Before I start, so this is me trying to understand the problem myself, like what I read, do I understand it? Now if I can state it in my own words, just sitting down and raising my head and stating the problem in my own words, then I can say, okay, it's time to move on. I understand the problem. If not, I go back to read the problem again to make sure I understand what they are looking for, right? Now, after that, the step 3 is constraints. So after thinking aloud, and I'm like, okay, Vim, I understand the problem now. So what I put the in comments, right? So again, everything I say I'm putting it down in comments. The reason why I'm using comments and not a piece of paper is because it is proctored, right? I'm not saying it is bad to use a piece of paper. It's if you can capture yourself well in a camera using writing down on a piece of paper and all those things, you should be good to go. But me personally, I'm not going to risk it. I can do everything on the screen so that the system sees it, and then no, I don't have any issues, right? So I would comment, I'll just create comments within my coding space, and then I'm putting everything down there, my thought process and everything. So I put in this is the expected input, this what the output is supposed to look like, what data types are we working with, any edge cases, any ranges, right? Like as I mentioned with the even numbers, are we talking about any random number of numbers or numbers between a certain range and all those things, right? Then the other thing is step 4 is where I look at the test cases and I'm like, okay, so these are the test cases. This is what the output is supposed to for this input per the problem per the problem I understood. For this input, this is the expected output. Then for this input, this is the expected output. Like things like that. That's why we do the test cases. So the test cases help you even understand the problem to a deeper level, right? So you already know, you can start seeing patterns at the test case level. So you have like 3 test cases that are already given to you, and from the 3 test cases you can see a specific pattern that is flowing through, and that already starts putting some thoughts in your head that okay, so maybe we are going to have a nested loop or something, right? We are going to do this, we are going to do this. It's not a part for you to think critically, but it gives you ideas, right, as to the direction your mind should be going. And that is the importance of the problem solving framework, right? It helps you fine tune your mind in a certain direction. It forces your mind into concentration. So by the time you get to the pseudocode stage, your mind has been aligned in a certain direction, right? So that is the understanding of the problem. You restate the problem to be sure that, oh, okay, in my own words, I can restate the problem. That means I understand the problem. Now I figure out more constraints, and then I also was look at the test cases, relating the test cases to my initial understanding, and making sure that yeah, I have like how the program is supposed to work and the output is supposed to give, given certain inputs and outputs, right? And then when I'm done with this understanding phase, I can now say, okay, now I have enough information from the question, and then I can now focus on writing a pseudocode. Now I come and see, okay, my usually and so in plain English, right? So my program is supposed to do this, it's supposed to take in this, it's supposed to do what it has taken in, and then do this with that, do this with that, and then at the end of the day, it's supposed to read how to solve the problem before implementing it. And skip pseudocode and get into the reason why is you can get lost in your code. There are times in the previous session, somebody said at first it was God and I who understood. Now it is just God who understands, right? I'm sure we've all been in that situation before. You're writing code, it's like, okay, now I understand. In the like head, and now I don't know, it just gets entangled, and then you are lost in your code, right? And that's what we are trying to prevent. So we have about a problem, write the steps we are going to use to solve the problem in plain English before we implement it in code, right? This helps us because if we are implementing it in code and then there is a fault, we can easily come correct it in the in the pseudocode and go back to the code and continue again. So during implementing the code now, we are not thinking um, um, we are not actually doing the problem solving thinking while writing the code in the implementation phase. We are just translating the pseudocode into actual code, right? Anytime we have a problem and we see that it's not working, we go back to the pseudocode, think in the problem solving approach, fix the pseudocode, come back to our code. Now, we said you get lost in code. When you get lost in code, always go back to the pseudocode as a reference. You don't have to sit and you're trying to figure out, you are now tracing this will do this will do this, and everything is so abstract. You are doing everything in your head. No, you have it written down somewhere. So anytime you are getting lost in the code and as to why you are doing what, you can come back to the pseudocode and say, okay, and then you quickly go back and fix it. And that is the importance of this framework, right? So this framework is going to help you understand and also keep track of whatever you are doing, such that you don't have, you don't get lost, and that would, in the long run, affect you, impact the quality of whatever you're writing or the speed at which you produce your solution. Generally, you would think that this is like a stressful or a long procedure, right? And I'll say yes, it's a long procedure if you have met the question before. If you have met that task before, you have seen it somewhere before, you have solved it before, I mean, there is no need to go through this again. It's a problem you have solved before, so you just have to solve it again. Whatever solution you give, you just have to reproduce the solution. There's no need to go through all this, and that will be faster. Meeting a problem that you haven't met before, if you are not strategic about it, you are most likely to waste a lot of time going in circles. And this is another thing that affects us during timed tests, right? Whenever we are put into a test and given a specific time, we rush into the test without actually planning. And this is one of the things that goes against us, right? Now, this is here to help us solve that problem, right? And we are here to also introduce it to you so that you would practice it whenever you are solving these problems, right? So again, if you have any questions, you can always ask. We would move on to the next slide. I'm sure we do understand what we are doing at each stage now, as I described. I think the next slide should be us working on a problem. Yes. working on a problem with this idea that we just discussed. If we have any questions, don't be shy. Ask your question. We will answer. We are here to answer your questions and to give you hope. We are the hope for the hopeless. All right. I'm guessing there are no questions. I was just looking to see if anybody will raise their hand and ask me a question. The people are quiet. I hope you are here. The weather is interesting. Somebody might just fall asleep. All right. So we have the leads. We have a problem from lead code. That's a two-sum problem. This is the first problem. This is the easy one. Admit. Okay, so this is an easy one. It's a popular problem that we have. I'm sure most of us here have seen. If you've not seen it before, today you are seeing it. But it's a very popular problem on lead code, right? We are going to use these steps to solve the problem, and then we get to understand how to implement this framework, right? So let's head to lead code and use the IDE to solve the problem, right? Okay. Now, first thing I would say is don't be worried about the programming language we're using to solve this. You might, sorry, I think I have to log in. Sorry, let me just log in and share my screen again. Quite strange. It just logged me in. I didn't do anything. Very interesting. Let me check the other one. Okay. All right. So we are back. Now, this is an easy level problem. We have a lot of problems on lead code that you can try your hands against after this. And I encourage you to sacrifice a lot of time into solving a lot of these problems before you go into the actual test, right? Okay. So now let's proceed. I would like us to do this together, but because of time, we spent a lot of time trying to fix whatever issues we had at the beginning. So I'm just going to go through it with you guys. And please, let's make it interactive. If you have any concerns, any issues, you raise them as we move. Sorry. Yep. If you have any concerns, any confusion, you raise them as we move and I will tackle them, right? So you're just going to see how I would approach this and can learn from that, right? So the first is we have to read the task twice. Yeah, we have to read it twice. So given an array of integers, nums, right, and an integer target, return indices of the two numbers such that you and may not use the same element twice in any order. Then we have the examples here. I just take a brief look at them. And then I take a brief look at the constraints with our array, which is nums, cannot have a length which is less than 2. So it's either 2, the length of the array or the input is either 2 or more, right? I'm going to just assume this is infinity because 10 raised to the power 4, that's a lot of numbers that we, right? Now, same here, 10 raised to the power, right? So this is our array given to us, right? The numbers are the various indices, these numbers can actually be negative numbers or positive numbers. So it can be negative, a lot of numbers down, positive, a lot of numbers up. Then the target itself, which is in this case 9, right? The target itself can be negative, a lot of numbers down, or positive down. Yeah. And we can have only one answer, right? So that means the output can be just an array of 2 numbers, right? So you can see that when I got to the constraints, I already at this point somehow taking note of the constraints. Then I come back to this this again. I'm coming to do my second read. Now in my second read, I do this, right? So I do this. Yep. Now, given an array of integers nums, right? So I'm an array of integers nums and an integer target, right? So my input is basically an array of integers of ints and an int dealing with numbers. Another thing I want to take note of here is I'm returning the indices and not the numbers themselves. Right? Return the indices of 2 numbers such that they add up to the target, right? Now, so these are the constraints I'm just writing down. If these are the constraints, right? So this is me on my second read, just noting things down from the question, right? You may assume that each input will have exactly one solution. So only one solution or answer exists, right? Then you may not use the same elements twice, right? That means you cannot add, you may not use the same element twice. Yeah. So you cannot add an element at a certain position to itself, right? If we are talking about, yeah. All right. So looking at this question, does anybody think I have left out any critical thing? Like, is there some constraints that I read and I didn't capture or I left out or something? Hello. Hello. Yes, Ebenezer. Eben, we can't hear you. Ebenezer. I can't mention the other name. I'll just stay safe. Christopher, you think it's good? I saw your thumbs up. Am I audible? Hey, can somebody hear me? I hope I've not been talking to myself all this while. Oh, okay, okay. I think Ebenezer said his network. But yeah, Eben, do you think I've left anything out? The constraints? You can just type yes or no. All right, I'm going to continue, right? So let's go back and see what we are doing. So the first step was that's where are you? Okay. First step, we read twice and then we figured out constraints on B, right? Now we have to restate our problem. Now I get back here and then all right. So from my first and second read, I identify some constraints and all that, right? So basically, this problem is saying I should write a program that is going to accept two inputs. The inputs, the first input is going to be an array. The second input is going to be just a number, which is the target number, right? What the program is seeking to achieve is it's supposed to find two numbers within an array, within the given array, two numbers that when you add, you are going to get the target, right? And then you return the indices of the two numbers, not the two numbers themselves, right? So that's my understanding of the problem. See, now I feel confident. I feel like, oh, nice. I understand the problem before I now approach the problem, right? So now, after getting my understanding, I go over the constraints again. Is there any constraints I have left out, right? Is there anything I want to add to this list? Now, I can look at the constraints at the bottom here, right? Even at the top here, I think I left out one. Yes, so this is to say, okay, this in the maybe you say 0 has to come before 1 or 1 has to come before 0. It clearly states that you can return it any order. So if you say you return 0, 1, it will pass the test case. If you return 1, 0, it will still pass the test case. So you can return it in any order, right? So don't waste time in trying to build a solution that uses a specific order. That's what basically it's telling you. So return in any order, right? That's another thing I want to put down. Now I go back down to confirm the constraint. Target can be either negative or positive, right? Now I have input here. My output should be an array of int of 2 int. That's from the question. That's what it's saying. That these are the constraints, right? So that is the step. So I have done the data types. I have considered the ranges which were in the constraints down there. Now the edge cases too are also specified in the constraints. When you read the constraints, you see things like we don't have to consider like an edge case of order, right? We don't have to for some situations we have to make sure our solution works for both negatives and positives. Then we also here we don't have to think about what about if we are working with a single element in an array and all those things. We don't have to consider that. Right? So these are things you're going to get to understand from your constraints, right? So basically we've done these two. Now, when it comes to test cases, what I would advise you to do for test cases usually would be to use the test cases that has been given to you. I typically would like to create my own test cases by flipping these test cases in certain patterns, right? So I just play around with these numbers to create my own test cases. This I want to kind of pass hidden test cases. And an interesting way to do that is to create your own test cases and add them to the original test cases so that if all the original test cases, the 3 test cases that you see pass, and then your 3 extra test cases you create also pass, you are sure that the hidden test cases will also pass. You have more confidence, right? So that's what I usually do. But for the sake of time and for the sake of the test, you can rely on the test cases that are giving you. I mean, if you want to use the same approach as me, that's fine. That's great, right? But just make sure that you don't waste time in creating your own test cases. Just play around with the number and you can have your own test case from that. Yeah. So you also look at these test cases to understand. So what has happened? Just a second. So what is happening here, right? You have an array, you have a target, now you have the output 0, 1. So you try to figure out how they get in the 0, 1, right? So from the question, you already have an idea. There are 2 numbers within this array that is giving us that when you add, you get the target 9, right? Now these 2 numbers that we are adding to get the target 9, how is the addition being done? How do we find out these 2 numbers, right? Now, these are questions you are going to start asking yourself in, so that's where the test case phase and Sudoku phase kind of overlap, right? So you see that's understanding that, okay, so if you go through the array, you see 2 numbers, you see 2 and 7. And when you add 2 and 7, okay, 2 and 7 is given us 9. And we are returning as output 0 and 1. Okay, yeah, it makes sense. The 0 and 1 is basically the position of 2 and 7. And the question was saying we should return indices and not the numbers themselves. It makes sense, yeah? So you just go through others like that, and this will enhance your understanding of the concept very well, right? Now, I am done going through that. I basically now hop into the Sudoku phase, and then I see, let me move on to the pseudocode. Right. So there are several ways of solving this problem. You can solve this problem with a hash map. You can solve this problem with loops and all that, right? But then I'm going to use the easiest way to solve a problem, right? You want to pass the test. You want to pass all test cases, right? So your focus shouldn't be in writing complex stuff or, yeah. if you can use an easy solution to pass everything, shall you do it? And then if there is time, you can optimize, right? So if there is time, you can now come and say, okay, I want to tweak my solution. But if you're optimizing, don't touch the working one. Come out, write your new code for the optimization. If time is beating you, comment the optimization out and uncomment the original one that was working and submit that, right? Again, this is a trick you have to always have at the back of your mind. The same thing applies to yeah, so even as part of that, if you comment something out and you need to work on something new and it's based on the first one, you can copy that one, paste it, and start working on it, right? So you copy the first one, paste it, and start alterating it. When if time is beating you again, you comment out the new one that you were alterating and uncomment the first one which was working and submit it, right? So let's go to pseudocode. Pseudocode, this is where I actually start my thinking, right? So I'm going to be like, what is happening here? What can I see here, right? So now I'm thinking with the data structures that I have in mind or something, but in plain English, right? So first, I try to pick a number, right? We are looking for two numbers. So my assumption at the beginning is first number is one of the two numbers. Then I put it somewhere and keep adding that first number to the other numbers, right? Apart from itself, because it says here that, where is it? Only one solution exists. You cannot add, yes. So you cannot add an element at its index twice. So if I pick 2, I can only add 2 to the rest. I shouldn't even waste time adding 2 to itself because I cannot get an answer at the same index, right? So I pick 2 and then I add it to 7. Then I get 9. So automatically, this is a best case. This is a happy case. I didn't even go through a lot. Now, another thing is I can have this same array. Sorry. So this is why I like having my own test cases, right? Because it helps me see a bigger picture. Because this is like what they have here is a happy case. Happy cases, Charlie, it's easy to spot. But then what if we have the 2 here and then 15 here and probably 7 at the end? That would give me a good understanding of how I can get it, right? And 7 at the end. And then we still have target as 9, right? So my target is still 9. So what I can do here is I pick 2, put it aside, or again, let me put 11 here and then put 2 here. So this is my new test case I'm going to work with. So I pick 11, put it aside, add 11 to 15. 11 plus 15 is not going to give me 9. So automatically, I know that 9 is not going to work. So 11 plus 2. 11 plus 2 is still not going to give me 9. It's not going to work. 11 plus 7 is not going to give me 9. It's not going to work. So I put the 11 aside and move to 15, right? Now 15 plus 2, not 9. 15 plus 7, not 9, right? So you see, I'm already like spotting a pattern, right? Now I can say 2 plus 7 is 9, right? I threw away the 15 and came to 2. Put 2 aside, trying to add 2 to the rest of the array. 2 plus 7 is already giving me 9, right? So this works. This works, so I can go to the next one again and see whether that same thing is going to work there. And I'm like 3, 2, 4. The target is 6, right? So let me see. 3 plus 2 is what? 3 plus 2 is 5. It's not giving me 6. 3 plus 4, also not giving me 6. Now we put 3 aside and pick 2. 2 plus 4, 6. So the same method I'm using at the beginning is working for example 1 and example 2, right? Then I come and do the same here. Pick the first element, add it to the rest of the array, which is 3. It's giving me 6. All right. So now I can say pick the first item of the array and add it to the rest of the array items, right? Now, wow, no. So if on a, so if we are, so we are adding to the rest of the array items, right? So if on a specific item, we get target, right? We get target from the addition. We do what? So if we get target from the addition, we return the index of the selected number in step 1, number in step 1, and the index of the item which when added to the selected number just a second, the selected number, we get target, right? So what we are saying is we pick the first item of the array and add it to the rest of the items. If on a specific item, we get the target, right, from the addition, right? We get the target from the addition. Then we do what? We return the index of the selected number in step 1 and the index of the item which when added to the selected number gives us the targets, right? So return it in an array. You can write this however you like. I mean, I am just trying to make it as obvious as possible because you guys are following, but I probably wouldn't write plenty English like this. I will have a better way to write it. And your approach can also be in writing it out in plain English. You can use whatever approach that works for you, right? So return, we can say return it's in an array. Now, what if, because we saw in this one that the first number might not work, right? So what if the first number doesn't work, right? So the selected number, which was the first number, if we add it throughout and we don't get the target, then we want to dispose that number and move to the next number, right? So we'll move to the next index of the array and use that as our selected number and then add it to the rest of our array. So if adding throughout the rest of the array, we do not get our target, right? Move to the next, right? Move to the next index and repeat the process with the number in this new index as our selected number. Right. So we are going to do this until, so if it doesn't work, we are going to repeat the process. We'll move the index, we'll move to the next index, pick that number as our selected number, and then repeat step 1 and step 2. If it doesn't work, we move the index again to the next number again, repeat step 1 and step 2. We are going to do that until we find our two numbers that give us the target, and then return the indices of these two numbers, right? So we are now going to translate this into code, right? Now, you would realize that at this point, I'm not going to be thinking again, right? I'm just going to be translating what I've written here. This is me now translating it to code. Now, it says I should pick the first item of the array and add it to the rest of the items, right? And then, so I read everything, right? If on a specific item I get this, I already have an understanding of this. Again, this is not natural because I am teaching it, but when you are doing it, you are going to already have, you don't have to come and reread what you have written down because you are the one who wrote it down. You already have the picture in your mind, right? Now, what you do is, from this, when you were writing this, you already had ideas of things you're going to use. For instance, since I saw repetitions, right, doing something until a certain condition is met, I know I'm going to use a loop, right? This part, the step 3, tells me that all this is going to be in a loop, right? Because anytime I hit step 3 and then we don't find the element we are looking for, then it means we are going back to step 1 to start all over again, right? So my loop is going to be here. I can say for I less than 0, for I equal to 0, I less than or equal to the length, not equal to, less than the length. These are things you should also be mindful of when to use the less than or equal to or less than. Yeah. If you are starting from 0, mostly you're going to be doing less than, right? The length, the array dot length, which is our array is from here, our array is nums, right? So we're going to have nums, or from the question, it says our array is nums. You can see it here. Now, you have nums dot length, right? Nums dot length. I plus plus, right? Now, if you notice something from the pseudocode, right? We are repeating the whole process over and over again till we meet a certain condition, right? So the first thing is, with this, we pick this number, we add it throughout. We pick the second number, we add it throughout. We pick the third number, we add it throughout. Something like that. So as we are moving from 11 as our selected number to 15, there is also another movement. So 11 here would first of all add to all these numbers before we can now move to 15, which also add to all these numbers before we move to 2, which will add to. So it's like we have 2 loops happening at the time. So that is the one that keeps track of which number is the selected number and which one is not the selected number, right? So that's the outer loop. So that's what we have as I here. Then we have the inner loop, which keeps track of which other number we adding to check to see, right? So we are going to have our second loop here, right? And the second loop is going to be J is equal to, here's J, here's J, right? So while the outer loop controls which number is the selected number, the inner loop is going to do the addition. So if you pick 11 as your selected number, you have to do the addition to everything here before you come out from the outer loop again, and then set 15 as a selected number, add it to everything over and over again, right? So that's what is happening. So this is what was described in step 2 here, right? So if one specific, so for step 1, sorry, pick the first item of the array, add it to the rest of the array items. So the first item is presumably our selected item. So you pick the selected item and add it to the rest of the array items, right? And that's what we are doing over and over again. So we have like an inner loop. So pick, add, then pick another one, add, pick another one, add, pick another one, add. So the picking is the outer loop, and then the addition is the inner loop, right? Again, you can make your pseudocode as explicit as possible so that you can always understand at each point what you are doing, right? Right. Now, we are saying that in the inner loop, right, we want to do what? We want to add, when we pick the item, we want to add it to the rest of the array. So we can say our sum is equal to, sorry. So sum is basically equal to, now our selected item will be I, right? So nums will be the item at index I. Index I plus the next item, right? So the next item, that means if we are dealing with the next item, then we are not dealing with index 0. That would mean this is supposed to start from 1. You get it? So the next item is index, it should start from index 1. So while our outer loop is at index 0, we can start from 1, 2, 3, 4. Then if it goes to index 1, we'll start from 2, sorry, yes, we'll start from 2, 3, 4, right? So let's clean this and make it I, I plus 1, right? So whatever I is, we start from I plus 1 to the length of the array, right? Now, this place is going to be nums, sorry, nums index what? So we are trying to add it to all the items in the array. So whatever we pick, our selected item is supposed to be added to all the items in the array. And then what we can say is here is J. So we are within this loop, we are going to repeat over and over again till we exit this loop, right? So I stays the same until this loop. When this loop ends, then I will change. I becomes the next number 15, right? Okay. Now, we can decide to, so okay, for this, we are doing this, we are returning this, right? Sum, in the beginning, we can say sum is equal to 0 so that we can be updating sum as we move, right? Right. This is not even necessary. So now, over here, what we are actually saying here in step 2 is if a specific item we get, if on a specific item we get targets from the addition of the two indices, right? Select from the two indices, what does it say? Return. We are supposed to return it in a return the two index of the two numbers in an array. That's what we are saying here, right? So here is supposed to be like an if statement, right? So we don't even need sum, right? So we say if, right? So if the selected number plus our current number, which is the next number, right? And then the next and the next and the next, right? So if this gives us our target, if this gives us our target, then what do? We return, what are we returning? We return the index of our, just a second. Oopsie. Yes. So if this plus this gives us targets, we return the index of these two, then the index numbers. So we are going to return in an array. We are returning it in an array. So that's what we have to take note of. I and J, which are the indices, right? Right. Then yeah. If not, then the loop continues to execute, right? So this closes here. I think we are missing one. All right. So what I'll do here is I'll just add a console log so that we can see whatever is happening. I use console logs to debug, right? So I can see what is happening and I know where an issue is and I can spot it and all that, right? So I'm going to console log. For the Python users print, you can use print, right? So I'm going to console log what am I console logging? Yes, these two numbers. Just to see what is going on. All right, now we can like run it and see what happens. All right. So we have our what? Okay, it looks like it's already passing. We don't have any errors. Outputs. Just a second. Oh, okay. Yeah, I know what's happening now. So I didn't intend for this to be a plus. I just needed to see the two numbers. Right. So you have 2 and 7. All right, sure. So you can use, I put the console log out here so that we can, wherever you're having a problem, you can always use console log to see what is happening at that point of your code in the std out, and then you use that to figure out, maybe you have an idea why that is happening and you can figure out your issue, right? Yes. So this is like one way to solve this problem, right? Guys, are you with me? Sorry, I lost my internet. Are you guys here? Everybody hear me? Are we together? All right, perfect. This is one way to solve the problem. And you realize I didn't just dive into the problem. I went through the problem thinking process. It's not going to be as long as this if you are using it. You'd realize they are overlapping, like there are periods where, or in the planning process, there are times where some of the phases overlap, right? And also you are not going to be explaining to anybody. You are doing it yourself, right? So the pace is going to be way faster than whatever we did here. But this is me trying to explain it to you so that you see how it works, right? So you can use this to solve other questions, or even the same question. There are many ways of solving it. You can use the 2-pointer approach. In the previous session, we used the 2-pointer approach, where you have a pointer at the end of the array, you have another pointer at the end of the array. So you add the first, the what is at this pointer to what is at the last pointer. If the two of them, if the answer is if the answer or the result you get is greater than target, then you move the pointer from the left or right. This right, yeah, from the right. You move it towards the left, right? If it is less than, you move this one towards the right. And then you add this number and whatever number is at the end. So you can use a 2-pointer approach. You can think about how to do it. Again, think about it. You write it down in pseudocode and then execute it, right? If you are doing it and it's not working, go back to your pseudocode, find out where the problem, in plain English, where the problem is, fix it in the pseudocode, and come back and rewrite your solution again. Spend more time on the pseudocode than on implementation. That is a trick. Your analytical thinking and all those things should be on the pseudocode. Once you have the pseudocode right, you just have to type out the code, right? Yeah. The same. So I talked about the 2-pointer approach. There's also another approach, which is the hash map approach, using things like dictionaries in Python. If you use a dictionary in Python or an object in JavaScript to solve this problem, you are going to have more efficient solution. You're not going to have two loops, right? You're going to have a single loop, which is if you know your big O very well, you know that is a more optimal and a better solution, right? But as I said, use the easy solution, pass the test cases, and then you can come back, comment out this, and build the new optimal solution that you have in mind, right? If you are done with all the other tasks, right? So you can comment this out to do the optimal solution you have. If there is no time, or if you are doing the optimal solution and time is beating you, what you can do is comment out whatever you were doing as optimal solution and come and comment this one and submit this one, right? So the trick again, this trick I am mentioning, I want you guys to use it. Don't delete code, just comment code out. Because if time is beating you, you might want to rely on that code. And if you deleted it, you'll be frustrated, right? So don't delete code. Don't worry about your work looking dirty. Look at all the cache I'm doing in my IDE. You can do all your cache here, right? And then submit your code at the end of the day, right? So yeah, this is the first problem we are going to be we're trying to look at using the steps that we learned about. I would pause for questions, and then we can quickly go into the next one, right? if we're able to end on time, right? If you're able to end in good time, what I'll do is I'll give you guys the opportunity to also brainstorm your solutions to one of the problems, and then you can write down the pseudocode and then we translate that. So I don't do the talking, you do the talking. Maybe if it's using the 2-pointer approach or using the hash map approach, right? And then you can also have a feel of how this works, right? So probably 1 or 2 people would help us with that, and then you can also build confidence or something. Yeah. All right. So we basically read twice, we restated, we took note of our constraints. We use a test. You see, even in solving, but relying on the test cases to keep everything together, right? So all these things play like an important role. We have to take notice of all of them. And we use all these things, what we have at the understanding stage, we use all these things to come up with our pseudocode. And then from our pseudocode, we just do translation. So where I'm getting, you realize that there were times where I would realize something and then I'll change it. But what drew my attention was what I wrote in the test case. I was like, the next, right? So, sorry, what I wrote in the pseudocode, we are adding to the next item, right? And that drew my attention to the fact that it is not either 0 or 1. I said item, we are the next item. So it's not a fixed number, it is a number relative to the selected item, right? So if the selected item is at index 0, then that number we are looking at should be at index 1. If selected item is index 1, then it should be index 2, right? So again, pseudocode helps you when like you are getting confused or something, right? You realize I started writing sum is equal to something, something, something here. This was me deviating from what I had written down in pseudocode. And I quickly went through the pseudocode and remember that I already have done the thinking. I don't have to do new thinking again, right? So I quickly cleaned that. Even though there's a way to make that work, I cleaned that because I already have the thought process there. I clean that and continue implementing what I have in my pseudocode, which is the if statement, straightforward, and all that, right? So again, the pseudocode is very important. It will help you, like it would help you focus to achieve the goal and at the end of the day. It is not, what is going to prevent is that scattered thinking, like you are thinking on the fly and trying to bring things together on the fly and all those things, right? Okay. Harp, sure. So we are done with the two, yeah, Amati, ask your question.
Please, I hope I'm audible.
Yeah.
So, in cases where you're using Python and then we want to use maybe some method, and maybe we are not really sure of how maybe the syntax of the method. I don't know whether we are allowed to maybe quick search on how the method works and maybe the inputs allowed on the method, and then we just come and use it. Maybe if it's it will help us quickly do the thing. I hope you get me.
What's the name again? If I get you right, you're asking if you can do, you can look up syntax, right?
Yeah, something like that.
That is a dicey question. It's dicey because at the end of the day, there is a component of the test that is trying to get to understand, know if you really understand the syntax. At the beginning of the slides, you'd notice that we said syntax is one of the fundamental things we are trying to understand, whether you grasp or you get the syntax of the language you have chosen. That's why you have the freedom to choose any language to use for this, right? Now, my advice generally would be once you get into the test, right? I personally, I mostly wouldn't risk going to do syntax lookup. It's allowed in code signal. it's allowed, but there are rules. And I personally don't, because of how it is structured, I don't want to even be in that situation, right? So mostly, if I can't find the high level or let me see if I can't find, those methods that are already the pre-built methods and pre-built functions that you can use to kind of solve your problems quickly. If I can't find them, then how do I use the basic stuff to actually solve the problem? Because these predefined functions and methods are built on top of the basic stuff, right? The basic stuff are our flows and controls and loops and all those things. How do I use that to achieve that? Right? And then I don't mind writing the most basic code to meet my goal than switching to go and do lookup syntax and all those things, right? But probably when you are reading the rules in for taking your code signal test, you can read all that and understand the rules. If you think you can play within the rules, you can, I mean, but to me, it's too risky, too risky. Yeah. All right. Sure. Okay. Any other question? This particular group, you guys are quiet. Are you guys hungry or is the weather? Wow, quiet too. Hey, I don't like a quiet class. If there's a class captain here writing names of talkatives, then your job, there is not important too. Because these people are very quiet. Even their laughter is quiet. Anyway, all right, sure. I'm guessing we are all fine, but does the approach we are using to do the solving doesn't make sense? If it makes sense, give a reaction. Like, see how many of us are getting this, and if we think this is a smart approach than just hopping onto the task. All right, all right, all right. It makes sense for some. Some are not responding. If you are sleeping, God has seen. Anyway. All right. Oh, somebody says their internet is lagging. Don't worry, God is in control. We'll share the slides to you guys after this. I'll get someone to share it to you after this. German. If we are giving money for questions, the German will get the money.
Yeah, because I took my test before this GCs are coming, so I'm not getting it yet. So I'll really wish to raise my test again.
Oh, okay.
So I've even forgotten my question, Kra. Yeah, Charlie's gone. So with the timing, in this case, if I'm to focus on one question, maybe my strategy is to focus on just the first question and get the first question right and very well. Am I very sure I'm going to get past the pass mark? Just in case I'm beaten in the question, like with time.
All right. So what I would say there is, oh God, these people keep calling. All right. So what I would say there is, this approach is meant to save you time, right? That is the approach. So you still have to have the fundamentals. You have to do the learning and the practicing and all those things, getting used to the various data structures and all those things, getting familiar with very different types of problems, using things like hash maps and the likes to solve your problems, right? And the different methods to solve your problems, right? Now, this process or this program or this meeting we are having is to tackle the fact that people might be conversant with these things, have the potential of passing the test, but fail the test due to poor planning and the way they approach their task. Now, what happens is most of the times when we sit, me personally, in a number of times when I sit on a DSA task, I just rush through the task. Like I see the task now, as I'm reading, I am solving. While reading. A very bad approach because at the end of the day, you end up going in circles, and that's what we are avoiding, right? This is for you to like read, arrange your thoughts before you put down anything, so that you don't waste time in thinking particular that I've been talking for a long while. I didn't realize I was muted. All right. So I was saying that generally the summary of what I'm saying is you passing the test is a combination of using this approach with the understanding the fundamentals of DSA. If you don't understand the fundamentals of DSA and you rely on just this approach, trust me, you are not going to pass. Right. Now, if you understand the fundamentals of DSA and then you apply this approach, what this approach is going to do for you is going to save you time for these tasks that you have not seen before. It's going to save you time. If the are tasks that you've seen before, I mean, the fastest way is to just hop on it because you already have the solution, you know the solution. And even with that, I would advise that you write down the steps somewhere in a comment before you start writing the actual code, because when there is pressure, there is the tendency of you getting lost in your thoughts. You are thinking about sometimes you realize that you have the idea how to solve it, and in the middle of solving it, you realize that you are lost. Like you had the idea before, but you don't know what is going on in your head now. That's the importance of writing down. So even if you've seen the problem before and you know the solution, write down the solution somewhere before you now start. Like write it down in pseudocode or something before you now in plain English before you start writing the code, right? But if you've not seen the problem before, this is the best approach to save time instead of trying to like jump on the task just like that, and then you end up going in circles, right? Samson, you had your hand up.
Please, good morning. I
Good morning,
wanted to
Samson.
ask a question about the marks. When open code signal, it says each question carries a total of 300 marks. But if you check the Amalitech page, you need to get 350. And there are 4 questions, which means the total marks is going to be 1,200 for the total score. I wanted to ask, how do they like do the calculation for the marks? Because if I solve 2 questions, that's 600, but there are 4 questions and each question carries 300 marks. Yeah, that's my question.
So again, the technicalities about how these calculations are done, I don't know. I've not really looked at them. Amalitech is not responsible for this. I think the marks are done, the system handles it, code signal handles it, and I think that it scales it down at the end of the day to a scale of from 200 to 600, right? So 200 being a fail, 600 means you passed every single thing in the test, right? And then the pass mark for us is 350. So at the end of the day, if the scaling down is done to 350, you should be is done. If the scaling down is done and you have 350, you should, that means you have passed. What I would say add to this is, what I know for sure is, if you finish the first and second task and then you have touched the other two tasks, if you pass all the test cases in the first and second task and then you touch the other two tasks, there is, I would say, an 85 to 90% chance of you passing the test. That's
Thank
what
you.
I know for sure.
Okay.
Yeah. All right. Okay. Do we have any further questions? Can I move on now? Okay. My assumption is I can move on now. All right. So in the slides, you would have, yeah, breakdown of how to approach this, right? You can go through that later, right? So this like writing pseudocode, right? This is how I would write my pseudocode, because I can look at it and easily understand, right? I wrote it in plain English so that we are all on the same page, right? Yeah. So as I was saying, I didn't do this because I want you to understand that you can write the pseudocode anyhow you want. As lens to you, right? And then you can see this, you can see the hash map option. Just looking at that, you can try to slides are given to you, right? So now we can quickly hop on to the next one. And then if there's guys also think about other solutions to the first task, and then we can call it a day. Now, the next task, but again, it's not about the complexity of the task. It's about the framework we are using to solve, right? The complexity of the task there is based on familiarity, right? And based on constant practice. That's what will help you guys. So again, after this, you have to keep practicing and practicing. So we're going to use the framework again to solve a medium level challenge on Lead Code called anagrams, right? Group anagrams. All right. Now let's quickly go back to Lead Code if we don't have any questions. Before we start, everybody is going to unmute and say hi. So I know everybody is fine. Nobody has collapsed. DLC, dear. When we're in university, some people collapsed in the exam hall. So let me make sure that everybody's intact. I haven't taken anybody's child to the hospital. All right. Everybody say hello, unmute, say hello.
Hello. Hello.
Hello. Hello.
Okay.
Hello.
I had like 5 hellos.
Hello.
Richard. Moses. Obed has collapsed. Obed. Hafsa. Hafsa, did I hear your voice? All right. Somebody call 911 for Obed and Hafsa, right? All right. Let's continue. Anagrams, right? I don't know if I'm pronouncing it right, but yeah, let's move. Let's move. Oh, Hafsa is here. Hafsa says she doesn't need the ambulance again. So whoever is calling the ambulance, we're just calling them for Obed. Obed gave a thumbs up. He says he needs the ambulance. So all right. So the second one. Now the second one I would use. Okay, here let's go on. We'll see how we're going to solve it together, and then we can move. So the second one is talking about anagrams, right? It is given an array of strings, group the anagrams together. You can return the answer in any order. Exactly. Here again, we are allowed to return our answer in any order. We don't have any specific order that we have to put the answers in. Right. Now, we have examples here. I briefly look at them. And from this, I can understand what anagrams are. I'm into Brofo. I don't understand English, so it's good that just looking at the question, I can already understand what anagrams is. But in some test areas, they highlight the keywords for you to get the understanding, right? So you can easily see what an anagram is. It says an anagram is a word or a phrase formed by rearranging the letters of a different word or phrase using all original characters except exactly once, right? So this is going to mean that for anagrams, you are not going to have like we are going to have like a set of characters that are rearranged to form words, something like that. That's what an anagram is, right? Now, from our example one, we can see that we have a list of words that is giving us an output and an array of arrays that is giving us an output, right? We have example two, we have an empty string, yeah, and the output is an array. We have three, which is also a string with a single value or a single item, sorry, an array with a single item, and then what we have as, yeah, also an array of arrays as returned. So our output is basically an array of arrays, and our input is an array of strings. That's what we can see here, and it states that in the question, an array of strings, right? Then constraints, yeah, we can have our constraints here, which is one less than so here we are talking about the length of our input. The length of our input basically is either one item in the array or more. So it cannot be an empty array, right? The second one is, the second constraint is telling us each item in the array is of length 0 or more. It cannot be negative, right? Then the last item is saying each item in our input array is going to be of lowercase, right? Now that's my first read. Now my second read is identifying constraints, right? So I'm going to just have constraints again. Constraints. Yeah, I'm going to have the constraints here. Now, the first constraint I can see is given an array of strings. I can say my input will be an array of strings. My output will be an array of arrays. So one thing in your studies is you should know, like, each, when it comes to data structures, understand them very well, especially manipulating them, right? Just a second, we have to log in here too. Yeah. So learn these things, learn the structures well, learn how to do manipulation and all those things. We have how to manipulate arrays, how to manipulate objects. These are things that come in handy whenever you are solving these tasks, and you see some of them here. And it also relates to the question, I think, what was his name? German asked, right, about looking up stuff. Yeah. So when you understand the manipulation of these, you understand these things very well, these structures well, and how they are manipulated, you are less tempted to even search for some of these stuff, right? Yeah, just to avoid having to search for these tasks, because even though searching for syntax is allowed, it's a risky ground that I feel like it's not worth taking. Yeah. All right. So we have inputs, outputs of arrays. Um, Now it says group the anagrams together. Yeah, so the output, that's because it says group them together, right? We are grouping the anagrams together. That means we are definitely going to be working with an array of arrays, right? So it's gonna be a, yeah, an array of arrays. Give me a second. Okay, let's continue. An array of arrays. So now, it says what are we returning? Yeah, we are returning the grouped stuff, right? So return the anagrams, right? In any order. The grouped anagrams in any order, right? Then we come down to our strings down there, which says before I even go there, I can try to understand the question, like just restate the question to myself, right? So I am given I'm given words, a list of words, right? And this list of words are words that some of them have the same characters, right? So I'm trying to group all the words that have the same characters. For example, eat and ate, right? Eat and ate have the same characters. So I ate banku. I will eat banku. Yeah, those two, eat and ate, have the same characters. So they are an anagram. So in the array, I should be able to group these together and group other anagrams together. So I'm doing groupings based on anagrams. Makes sense. I think I understand. And then I return the grouped version of the array. So after grouping them within the array, I return the array of groupings. Right, makes sense. Now I continue with my constraints. I can say I have constraints. One says the length of our array, right? The length of our array. Where are you? Says what? The length of an array of our input. Length of inputs. So input is just a single array, right? Array. Ha. Can be one or greater, but not less. Right. The second one says the length of the strings themselves, right? The length of the strings themselves can be 0 or more, but not less. All characters are in lower case. Hence, no need to handle cases. So you don't have to convert cases or assume what if somebody inputs an uppercase or a lowercase, or all of them always are in lowercase, right? Right. So this is me finishing these steps. So I have here read twice, gotten my constraints, restated my problem, and inputs, outputs. Do we have the outputs? Let me see. Yeah, we have our outputs here, inputs, outputs, and all these things here. So we've already conquered like 1, 2, 3, right? Now we just look at the test cases to see what we have. When we go back to the test cases, we can say, okay, this has this. So again, this is just restating what they stated here. You can have like an empty string, but not an empty array, right? Which was stated as part of the constraints. Then here we can have a single item, a single character, right? Yeah. So again, we can have an empty array, right? The array always has something in it, right? So these are things we notice from our test cases, and in our test cases we see eat, t, tan, whatever, and what we see is we have an output of but we have only one item that has BAT or ABT or whatever, right? We have this, we have, yes, so all these have the same characters, all these have the same characters. That's why they are grouped together. Now in this case we have only one item, so that one item becomes the outputs, right? Same here, we have only one item. That one item becomes our output, right? Which makes sense. Now we've gone through the what's the name? The test cases. Do well to always read these things. They give explanation to what is happening in the test case, just for clarity's sake, right? And then now that we have done all this, we can move forward to writing pseudocode, right? Now, when I look at this, what comes to mind? Now, I have to identify. Okay, so now back to pseudocode. When I think about this, what comes to mind in writing my pseudocode? The thing is, I have to identify the words that have the same characters, right? And this is where the importance of how you use your data structures come in, like knowing when and where to use certain data structures and all those things, right? Because it makes it much easier. Now, how I look at this is we have a group of words, some of the same characters, and we want to group them. What I start doing is, how am I going to identify those that have the same characters? Just looking at them, EAT, TEA, ATE, they all have the same characters, but they have been like interchanged in different positions, forming different words, right? And then this takes me back to, I think, was it level 200? Either 200, I think 200 or second semester 100 or something, where we're talking about ASCII and those things, right? Now, ASCII, when we talk about ASCII, we have like each character has its own ASCII value, right? And that means we can have an order, right? We can have an order for characters. Thinking about it, we can have an order for characters. So that means even though they are letters or their characters, there is one that's which will have a lower ASCII value and one will have a higher ASCII value. So probably if we can rearrange these characters, we can rearrange them to form like from lowest to highest, each of them, right? From lowest to highest. Then what is going to happen is it, and T will all have will have the same characters organized from smallest to highest. So hold on just a second. All right, sorry for the break. Yeah, so you can rearrange them, and when you rearrange them, what is going to happen is we have uniform words now. So eat. So you can say if for eat, T, and 8, what can happen is we will have A coming first, E coming second, and T coming last, right? AET when we rearrange them. Right? So we can then say that all the words that are rearranged, right? Let me see. Yes. So if we rearrange the words and they conform to this AET pattern, then we put them in a particular array, right? We put them in a particular array. Then at the end of the day, we return that array. And then how we are going to make sure that we keep track of all these arrays is like a dictionary, right? So I can see more like a container. So I'm looking at a container where I can have more a dictionary is what I'm calling a container, right? A dictionary or an object, right? So I can have an object that has AET as key. Another key would be ATN, right? And then the last key will be ABT. Right now, if I find anything that conforms with AET, I push it as a value into an array for AET. If I find any word that conforms with TAN, sorry, AN, right? Or ANT, sorry, ANT. If I find anything that conforms with ANT, that ANT key in the object or in the dictionary, I push it into an array as value, and then like keep searching for words that conforms with the same pattern. And the same with the ABT, right? At the end of the day, we are going to have a key, which is the sorted pattern, and then values, which are the actual words that conform with the sorted pattern, right? So this is trying to put all that we know into play, like something like that. I don't know if we get it, but when we write the pseudocode, we'll probably get it better, right? God, so help me, God. Let me remember everything I said. I should have been typing them down. All right. So the first thing, I literally spelled out the steps without writing them down. The first thing, yes. So we have like an object, which is the container, right? So a hash map. So we have an empty map, initialize, or declare. Let me use declare an empty hash map. Yeah, so we have an empty hash map, right? Now, we talked about sorting each of these characters, right? We're going to like sort each of these, right? Now, what is going to happen is, just a second. Oh, I have to join this. Sorry, yeah. 27. Okay, so we declare an empty hash map, and now we have to like create a dictionary where the keys are the sorted values of each of these strings, right? Each of these strings in the array. So what we are going to do is a loop. We are going to pick each item. We're going to pick each item. We are trying to sort it. Then after sorting it, we are checking to see if that item already exists in our hash map as a key. If it doesn't exist, then we create a key, and then the actual word is put in an array as value for that key. If it exists, we are just going to append the actual word to the already existing array of that key, right? So we would pick an item at the current index, right? Pick an item at the current index, sort it, check and sort it. Index. Yes. And sort it. Then after sorting it, we will check if the sorted, we'll check if the sorted the results of the sorted string exist as key in the hash map, right? For if it exists as key, then append to the value which is an array. Append to the value will be an array because we are each keyword have like a list of words, right? So which is an array, append to the value which is an array. What are we appending? We'll append to the value the actual word, the unsorted, let me see that, unsorted item or word. Append to the value the unsorted item or word. Yeah. 5. Else create. Else we create. Else we create the new item in the array. Sorry, in the hash map by setting the sorted word as key and the unsorted as value in index 0 of an array, the first index of an array. Then 5, 6. We repeat step 2 to 5 for each item in our array. Then return. So we return, what are we returning? We return an array return an array of, oh no, we just return the object values. Returning the object values should give us an array. So return in an array the hash maps values. Right. So this is me spelling out the steps we are going to take to like solve the problem, right? So first we declare hash map, then step 6 indicates that step 2 to step 5 are like going to happen in a over and over again. That's a loop, right? So we pick an item in the current index and then we sort it. Then we check if the result of the sorted string exists as a key in the hash map. If it exists as a key in the hash map, then we append to the value, right? And then the value is an array, right? So we append to the value the unsorted word, not the sorted one again, right? So what is going to happen is going to look like we are going to have something like this. So here we can have like an empty hash map. Then here we can have something like when we sort, pick an item in the current index sorted. So in the when we sort, the first item will be AET, right? Let me just do this, right? Now AET, right? Now after that sort, we get AET. Now in the hash map, we say, well, check if the results already exist in the hash map. We've checked it doesn't, the hash map is empty, doesn't exist, right? Then the next step is what? If it exists, append. It doesn't exist, so we'll not do anything there. Else, this is where we are handling if it doesn't exist. So if we are going to now create it, AET, right? And then it says what? Append to the, if it doesn't exist, we create it an index 0 of the array. We put in the actual word, which is it, right? Now it is here. Now we are repeating. Step 6 is repeat 2 to 5 for each item in the array. So we go to T, right? Now we pick an item in the index and sort it. So T, when we sort T, we are going to get AET, right? Now it says check if AET, for the second one, when we sort, we get AET. We are going to check does AET exist? Yes, it exists. So if it exists as key, then append to value, which is an array, the unsorted word. The unsorted word is what's T, right? So we are going to append T, right? So T is what we are going to append, right? And at the end of the day, we have this here, we already have AET in it. We already have EAT, and then we are going to append T. You see the pattern, what is happening here. Now, if we use tan, tan doesn't exist. So by the end of the day, we'll come here, and this by this stage here already has T, right? So we'll have here tan doesn't exist, so create tan, and then here would be sorry, here will not be tan, we ant, right? When we sort it to be ant, and then we have here tan, right? And the next word is what? 8, right? And then we continue like that till we populate this whole thing. And then when we populate this whole thing, we return the values, which are these arrays, not the keys. We return only the values in an array, right? I'm sure it thumbs up if it makes sense. If you have any confusion at this point, let me know. Okay. All right. So now we are coming to what we've done is we've basically completed all these steps up to pseudocode. We are now come to see how we are going to implement it as code, right? So what I'll do here basically is I'm going to have scene as my hash map. Have we seen it? If we've not seen it, we create it. If we've seen it, we append. That's basically the idea. Now, the next step is pick an item. And it's talking about repetition, right? I'm going to be repeating 2 to 5 over and over again. So it means 2 to 5 should be in a loop, right? And the loop should be the length of our array. We are doing it for each item in the array. So for I equal to 0, I less than strs dot length, right? Sorry, I plus plus, we increment, right? Okay, so we are putting all this in a for loop. That's 2 to 5, right? Now 2 says what? Pick an item. So we are picking the ith item, right? And we are sorting it. So we are going to say sorted is equal to so how do we sort in JavaScript? We are going to have to first split the string into individual characters. And then how we do that is we use the dot split, right? The dot split method, right? So we're going to have strs. We're going to pick the item at index I, which in this case I is 0. So it, we're going to pick it, right? So it dot split yes, so we're going to have it dot split, right? And to split into individual characters, we use this, right? If we are splitting based on space, then we'll have to put space here. If it's based on comma, we'll add a comma. I mean, these are things you understand when you get to understand string manipulation, right? So yeah, again, you have to, when you are learning the data structures, learn them into details, right? And see how you can manipulate these structures. So this is going to give us, this split will give us an array of characters, e comma t in an array, right? With e being at index 0, a being at index 1, t being at index 2. That's what is going to happen here. Now, when we split them into an array like that, what we are going to do is we are going to use dot sort, right, to sort the array from lowest to highest, right? Now, this sort is doing it based on the ASCII value, right? So it's using the ASCII value of the characters. So it will rearrange the characters based on the one with the lowest ASCII value to the highest ASCII value, right? Now, the next thing is after we have sorted them, can you guys see my screen? Can you see my screen?
Yeah, we can see.
Right, sure. So after we've sorted them, right, what do we want to do? We want to join them back together as a string again, right? Because that's what we are going to be pushing into our hash map, right? So we're going to have dot. Sure. So we're going to have dot join, right? And dot join is what brings it back together. So at this point, it's going to split EAT into individual characters and rearrange them into AET. So A comes first, E comes second, T comes last, right? So once we have sorted, right, and we've saved it in the sorted variable, what we are now going to say is step 2, check if the results of the sorted exist in the hash map. So we are going to say if sorted in scene, again, know how to manipulate hash maps, right, in your language of choice. So we're just checking to see if the key sorted, whatever is saved in sorted there, if it is AET, right, if it's in the object, right? So if it is in the object, what do? We say scene. So that item, right? We are going to say for that item, which is scene index sorted, this is how to access an item in an object. Yeah. Dot push. So we are updating the value of that item in the object, right? So dot push. So if it exists, then the value is what's the name? If it exists, the value is an array. And how do we update array? How do we add to arrays? If you try to do seeing objects, seeing index sorted is equal to, then put in whatever you want to put in, what is going to happen is going to delete whatever is in the array and replace it with whatever new thing you are putting there, right? So the best thing to do is to push. You are pushing to the last, you are appending to the last item of the array, right? So we are doing dot push strs. What are we pushing? The actual word itself, because it says if what else, if it doesn't exist, create the new item in the hash map by setting the sorted word as key, right? That's what is happening here. So this is the key, and the dot push is what is updating the value of that key, right? So setting the word as key and unsorted word as value, right? So the unsorted word is going to be, sorry, this is not where we are. This is if it exists. Yes, so this is step 4, if it exists. So if it exists, we have seen index sorted, and then we are going to push into, if it exists, then the value is an array. We are pushing into that array the actual word. So if it exists, then append to value. That's why we are using push, right? Which is the append to value, which is an array, the unsorted item or word. So the sorted item or word itself, which is strings index I, right? Index I. Now, else, we are moving toward step 5. Else, we are going to have scene index. So this is us creating a new key, right? Accessing a key and creating a new key are basically similar. What happens is it is going to check to see if it exists. If it exists, it would update it, right? You update the value. If it doesn't exist, it would create it and then put in the value that you are given to it, right? So that's what happens. sorted. What are we putting there? We are putting an array at index 0. So index 0 is the first index, right? So we are putting an array and then we are doing strs index I, the current item, right? Then 6 says, okay, that's what we've done for each item. So after the for loop, we can just put a console log. Let me see. Why are you here? Okay. So we can have like a console log so that we can see what actually is happening. So we have console dot log. So we want to see what the final output of right, what scene will look like. Right. Then we return what are we returning? We are not returning the whole object, right? We are just returning the values. The values are the arrays, right? These arrays that we form at the end of the day over here. So only the arrays without the keys. Sorry, yeah, only the values without the keys. So there's a value 1, value 2, semicolon. That's what we are returning. And how we do that in JavaScript is object. So I accessing the value object.values, right? And scene. That's how we do that here. We are just returning the right and see what we can fake come up. Yeah. Okay. So now we can see a picture here of what is happening. So in the first, it will split AET. Something happened here. There's no of the do away with the comments at the end of the day. But if they're still there, it's fine. It's still similar, like it still works, right? So we have this. So all these follow this pattern. That's why they are grouped together. That was what we spelled out here. And then all these also follow this pattern after the sorting, right? So, and then this one follows the ABT pattern after the sorting, right? Then at the end of the day, we return the values, which are this one, this, and this. We return them. And then the output is here as an array of arrays, right? We have this as output. Now, the reason why we had this outer array is object.values returns its values in an array, right? And already these are arrays. So these arrays are going to be in that array, right? If these were not arrays, they'll just be in a single array. One array containing items. So object.value, the return type is usually an array, right? Or it is always an array. Now case 2. Case 2, we have this, right? And it returns this. Now, we didn't have to for efficiency's sake, we don't have to go through all this to be able to return this. We can just handle, have an if statement that handles single items in the array. It should just return the same item like as a response, right? And you'll be fine. Yeah. But again, we are taking a test, Charlie. If I finish this, I'm moving on to the next question once it's passing the test cases, right? And then test 3 to same single item, right? So this is us explaining like everything. One thing you always notice is at the implementation stage here, I am not typing the code and thinking. I am just making reference to pseudocode. I type, pseudocode, I type. So this is not a stage for thinking. Now, what it saves me is I don't get entangled. Like I don't get to a point where I'm lost in the code and then I'm trying to figure out what I was doing, what I actually really wanted to do, and all those things. No, I don't get to that stage. I simply just look at my pseudocode and then implement, pseudocode implement. So the implementation stage is like the fastest stage. The stage is you take time to actually prepare for the implementation stage is where is a pseudocode stage. That's where you spend a little bit more of time, right? So basically that's the idea of using this approach, right? This planning approach to tackle your task. Don't just jump into the task if you've not met it before. Practice also, like practice with these things, practice and practice and practice until the day of the test, right? Let's move on. We have what? Okay, so I will pause for questions. Yeah, that's where we were, and that's what we solved. I'll pause for questions, and then we can continue. Yeah. Do we have any concerns? Any questions? Okay. So yeah, Amati.
So in cases where, for like example, this anagram like this, if I'm tackling this, maybe it will take a very long time. So if I do maybe I go through the process. I've gone through my pseudocode and maybe for some reasons my pseudocode itself is a mistake. There's an error somewhere. And then through my test cases, I'm passing maybe case one. Yeah. And then I check the time and then the time two is going. Can I pause and move to the next question and then try and see if I can maybe tackle that one too? Or I have to.
Yeah. I mean, you can do that. The questions are, that's why I said there is no blocker. You manage your time anyhow, right? You choose how you manage your time. So the questions are all available. You can skip any question, go to any question, right? The easiest one is the first question. The second question is the second easiest. And since I said passing the two gives you an upper hand, your aim should be passing the two. So if the first one you are delaying and you want to move to the second one and go and focus there, it's allowed. But just know that second one is much more challenging than the first one, right? Always have that in mind and know how you go around that. And as I said, learn how to comment out whatever you have done before you tackle. Don't clean, don't delete, comment them out, right? Before you go and type your new code. There are shortcuts for commenting. You don't have to learn the shortcuts. That is going to save you time. Yeah. Learn the shortcuts for commenting so that you just highlight and then press the shortcut and then let me see if I remember this shortcut stuff. Who remembers the shortcut for uh shoot.
It's
I think
control/.
yeah, control/. Yes. Yeah. Thanks. I was using alt/. Yeah. So control/, and then you are done, right? Yeah. Now, if you want to organize your stuff, there's also a shortcut that you can use. Maybe a number of things are not in line, right? What you can do is you can have something like this. You can have your cursor at multiple places, and then if you now press the space bar, it gives one space everywhere. If you press the delete, things like that, right? This is like alt, I think alt, then you click you want. So you hold the alt and click wherever you want, and then you are good to go, right? When you click outside, you're fine, right? So these are things that would increase your speed and all that, right? You want to also take note of that. Yeah. So, yeah, I don't know if we have more questions before I move back to the slide. All right. So the last part of the slide is talking about what I've been mentioning throughout since the first part of the slide, which is practicing. Practicing is very important because these things we've talked about in this project, right? In this last project can even be used to solve the first project. The what do we call it? The two-sum problem. There are patterns here that can be used to make the two-sum code even much more efficient. That's the advantage of uh, solving a lot of problems. For instance, you've seen something like object values in one. You can use that in another scenario where you just need the values. You don't need the whole object and all those things. These are things you get to understand patterns and see things, better ways of executing things as you solve more and more projects, right? So I would advise us after this, we don't just go and sit, get a steady partner. And every day, at least, you solve a question together. You can solve more than one question, but every day try to solve a question together. Something you can come in. Yeah.
Okay, please. I wanted to ask a question. When you are practicing with code signal, at times they ask you not to use maybe some built-in functions. But when I took the first test, you can use even brute force and it counts because they say they don't care about the time and space complexity. But when you're reading the instructions, at times they are like, it will be better if you can do this, like if you better if you can do that. So I wanted to know, does it like count in terms of like rating or giving the marks?
No, the main point of giving a mark is passing the test cases.
Okay.
That's why I'm saying you can go brute force, and then when you are done, you can decide to optimize.
Okay, thank you very much.
I think if a question needs to comply with time and space complexity, they'll state it there. But I don't think there's any question like that for you guys. I don't think you are tied to time and space complexity.
Okay, thank you very much.
Yeah, you're so, yep, as I was saying, let's practice more, right? Let's about 10 minutes more because more time would have gone through that to use other approaches to solve the task that we have solved, right? But as the time is up, I would say go practice more. These are resources that you can use to practice. Use them. Don't just let it end here. I have not given you a way to be more efficient with your time, right? All the knowledge to pass the test. That is dependent on you, right? And how many tasks you are going to solve before the test. Now, there is also the Yano who think they are better than, I don't know, who think they are good, they are sharp, right? Now, recruitment, Prince Davis will send you guys what's the name? An email, the practice test. And you have like 7 days. Do the practice test. You say no, you wait and take the test like that. Superman. Those people, it will shock you. Please do the practice test. Even if you are good. Come again. You were saying something.
The practice test it misled me at that time. It was very easy, but when I opened the test, now I realized it wasn't that easy. So I have
Yes.
to like
So
keep on
that's what I'm
practicing.
saying. Exactly. So you don't stay on only the practice test, but do the practice test. That I was coming to a point. Even if uh, even if you are good, right? What a practice test is going to help you do is going to pre the test or before the test. What it's going to do is it's going to I don't know, focus your mind. It's going to help you focus your mind, right? Not only the practice test and every other thing tool you are practicing with lead code, neat code, hacker rank, and all those things. Before the test, if you are constantly doing it, your mind is going to be focused in a particular direction for the test. You don't enter the test and you're now using extra energy to focus your mind, right? So this is also a hidden importance of practicing before the test. You put yourself in a certain I don't know how to put it. Would I say a certain aura or a certain, I don't know, a certain speed or a certain mood, right? A certain mood ready to take the test. That's what practicing does, apart from giving you more knowledge and helping you recognize patterns and all those things. It forces you to conform, something like that, right? So don't play with practice. Keep practicing and practicing and practicing before the exam. Sacrifice everything. Sacrifice a lot of things and then keep practicing, right? And combining this approach of this approach for working on new tasks you've not seen before and the knowledge you've gathered in the process of practicing, you should be fine, right? Yeah. Yeah, basically that should be it. I think we've touched on most of the important things for the GCA. We talked about the instructions which you're supposed to look, which you're supposed to read. We talked about some of your concerns which you raised. We also talk about the framework which helps us, and we are giving you resources to go and practice, right? I'll give you this slide so that you can use it as a guide to study. And then I hope to see you in Amalitech in the shortest possible time, right? Who has Vim? Samson has Vim. Only Samson has Vim. Okay. Amate has Vim. Hey, the rest of you don't have Vim. Ah, humble. Hey, humble Richard. Hey, your name is interesting. No? Richard. All right. Humble Richard. Collins. All right. If you don't have Vim, go and practice. The Vim, if Asante wa Chumesi night, go and practice. Practice. Yeah, Obet is hopefully nice. Yeah, so just keep practicing. You should be fine. Again, that's trick. The first two questions, make sure you kill them. You kill the first two questions. The others, you just touch them, and you should be fine, right? Jeremy, you have a question?
Yeah, please. I read that a link will be sent to us, to those of us who want to rewrite the code signal. So I don't
All
know
right, sure.
how we will receive it. Is it right now or through the mail?
Give me a second. Let me check if we have anybody from recruitment here. Francis, Prince Davis. Okay. They are not here, but you receive it through your mail. I don't know when you receive it, but it will come within a week through your mail. Is that okay?
Okay, so just in case, so like this one, edge cases, what if it doesn't come? How do we hit it?
Reach out to, let me put an email in the chat. Prince Davis. Okay. If you don't get it, reach out to Prince Davis. Yeah, so I've put Prince Davis's email in the chat. If you don't get it, you can reach out to him. Right. Okay. Any further questions, or we can end here? Right. Looks like everybody's fine. Steps 1 to 5, do the work. So that's where you actually do the work. Step 6, you don't do work. You just type. You are just translating whatever you have done. Keep that in mind. Keep practicing, enjoy your practice, and make sure to pass the test. I'm hoping to see all of you in Amalitech very soon. Thank you very much for your time. If you have any concerns, you can email Prince, and then if he has to reach out to me, he'll reach out to me. See you guys in Amalitech. Bye.
Bye.